In this video, we want to solve for x given 2 raised to power x plus 1 minus 3 raised to power 2x is equal to 0. We're given 2 raised to power x plus 1 minus 3 raised to power 2x is equal to 0. To begin, let us move 3 raised to power 2x to the right-hand side. This will then give us 2 raised to power x plus 1 is equal to 3 raised to power 2x. This expression here is of the form a raised to power m plus n. And by law of indices, this will give us a raised to power m times a raised to power n. So 2 raised to power x minus 1 becomes 2 raised to power x times 2 raised to power 1 equal to 3 raised to power 2x. This is simply 2 times 2 raised to power x equal to 3 raised to power 2x. Let us rewrite this as 3 raised to power 2x is equal to 2 times 2 raised to power x. Now I'm going to divide both sides by 2 raised to power x so that we can get rid of 2 raised to power x from the right-hand side. And then we are left with 3 raised to power 2x divided by 2 raised to power x is equal to 2. Let us apply another law of indices. Given a raised to power m times n, we can also write this as a raised to power n times m, which is also the same thing as saying a raised to power n raised to power m. This is so that we can write 3 raised to power 2x as 3 raised to power x raised to power 2, or 3 raised to power 2 raised to power x. This here is exactly what we need. So the equation becomes 3 raised to power 2 raised to power x, then divided by 2 raised to power x is equal to 2. 3 raised to power 2 here is 9. So we have 9 raised to power x divided by 2 raised to power x is equal to 2. Applying another law of indices to the left-hand side expression, given m raised to power a divided by n raised to power a, by law of indices, we can simply write this as m divided by n, then raised to power a. This would then imply 9 divided by 2 raised to power x is equal to 2. And now we have an exponential equation, and we can take the logarithm of both sides. So we're going to say log 9 over 2 raised to power x is equal to log 2. By law of logarithm, given log m raised to power n, we can also write these as n times log m, so that our equation becomes x times log 9 over 2 is equal to log 2. And then we can divide both sides by log 9 over 2. So that this here takes care of this, leaving us with x is equal to log 2 divided by log 9 over 2. By law of logarithm, given log p divided by m, we can also write this as log p minus log m. Therefore, x becomes log 2 divided by log 9 minus log 2. So whichever you prefer, either this or this, both can suffice as our final answer for this problem. Or we can simply convert this to decimal. X is going to be log 2 is approximately 0.301 and log 9 is approximately 0.954, so minus 0.301. Then x is going to be 0.301 divided by 0.954 minus 0.301 would give us approximately 0.653. And then we can get an approximate value for x, which would be approximately 0.461. This would then be our final answer to this problem. We can do a quick check to confirm that our solution is correct. We can check with this approximate value or either one of these two other values. Let us check with the approximate value. We are given 2 raised to power x plus 1 minus 3 raised to power 2x is equal to 0. Therefore, since x is 0.461, we now have 2 raised to power 0.461 plus 1, then minus 3 raised to power 2 into 0.461. This is expected to give us 0. This will give us 2 raised to power 1.461 minus 3 raised to power 2 times 1 here is 2, 2 times 6 here is 12, 2 times 4 here is 8, 8 plus 1 is 9, then 0, to give us 0. By my calculator, if I do 2 raised to power 1.461, this gives us 2.753 approximately, then minus, if we do 3 raised to power 0.922, we get 2.754 approximately. You can see these values are almost the same, so we should get 2.753 minus 2.754, which gives us negative 0.001, which is approximately 0. So it means that our solution is perfectly correct. Thanks for watching. Please like and share, and also remember to subscribe to my channel, and I'll see you in my next video. Bye.